For this class, we will introduce the special areas about OSPF. For the OSPF special area, why we have to set the special area? Actually, the special area can prevent the step area from floating unnecessary LSAs. So in our network, not every one router needs to know the detailed LSA information, because we know if we want to know every LSA information about whole network, we have to store the LSA information into our database, right? So we will occupy much CPU resource and memory resource to store it. So if we have the detailed LSA information, we also have to calculate the route information by the LSA information, and then we have to use the SPF algorithm again and again. So it also will reduce the CPU resources. Okay, this is another reason. And for the third, every router have to transmit, have to receive, have to send the LSA to each other. So it's not necessary for every router to do this action. So in order for the edge router to work better, and we suggest you can use the special area in OSPF process. So here we provide the different types of special area. First is the step area, and the second is totally step area, and next is an SSA area, and then the totally SSA area. Actually, for the step area and the SSA area, the differences between these two types actually is the redistribution. We can't do the redistribution on step area, but we can do the redistribution on an SSA area. This is the differences. Okay, so the last is transit area. Actually, is the features for the virtual link. We will describe these parts in SPF advanced features. So in this class, we won't introduce. Okay, for these four types step area, we usually used in the edge of OSPF area. So what's this mean? This means here we can see for this topology, and here is area 0, right? There is area 0, it's a backbone area, and then there's area 1, non-backbone area. And for the non-backbone area, maybe this area is the edge area, and for the edge area, actually, we want to communicate with other area, and for this area, we don't need to know the detailed routes, because if we want to communicate with other area or other routers, and we have to go through this router, which belongs with the area 0 and the area 1. So we don't have another or other ways to go to other area. We just have one way to choose. So here for this scenario, actually, we suggest you can choose set the special area for area 1. Okay, because in area 1, the device belongs to area 1 is the edge router. We don't have another or multiple way to access other area or access the external network. We just have one way to access other device. So now, if we know the detailed route, we have to store the whole network areas information. We also have to calculate the routing table by myself, right? And then I have to receive and send, and floating the RSA information is not good for our device. Okay, so next, we can see for the backbone area, actually, for different area, if the device wants to communicate with the external network, we have to get the type 4 and type 5 RSA information, right? if we want to communicate with a different area, we have to get the type 3 LSA information, right? And we use the type 3 LSA for inter-area communication, and we use the type 4 and type 5 LSA information to access the external network. So for area 1 device, if the router wants to communicate with other area, we just have one output, right? And if we want to communicate with external network, we also have to send the packet to this router. So it's no differences between we don't have the detailed route or we have the detailed route. So actually, if we set the spatial area for area 1 and the backbone area actually don't send the detailed information about type 5 and type 4 areas information, and even though won't send the detailed type 3 areas information, so instead of this, we will send just a default route to make sure the routers belongs with the area 1 can access the different area and also can access the external network. Okay, for the first spatial area, we will introduce the step area. For the step area, actually, if we want to set an area to become the step area, and we have ensure the area is the edge. So what does this mean? It means for this topology, we can see this router RD, right? For this router, if he wants to communicate with area 0 and area 20, he have to transmit the packet to RC device, right? And then the RC device can help the RD to transmit the packet to other device. Okay, and for the other routing, right, such as here is 1.92.178.10, and for this external information, if we want to access this external network information, we have to transmit the packet to RC, right? So actually we can see for the RD device, we have the detailed information, and we don't have the detailed information. There is no differences between two situations, right? If we have the detailed information, we also have to send the packet to RC. We don't have the detailed information. Also, we have to transmit the packet to RC device, right? So it's no differences. Now, for this scenario, actually, we can set the area 10 to become the step area, because for the RD, we just have one output, right, to access other area, to access the external network. Okay, and for another, no other routing protocol is configured. So what does this mean? It means if we set this area to become the step area, and we can't to communicate this area to another AS or to enable the other routing protocol on the step area, so that we can't do the redistribution on step area. Okay, so we can't learn the external network information through the step area. Okay, we can't do that like this. So for these 2 points, first is the edge, and second is we can't do the redistribution, right? We can't set other routing protocol. If we satisfied with these 2 points, so we can set the area to become the step area. Okay, so this is the step area. And for the step area, actually, we can learn the detailed information here. So first is it's allowed to learn summary RSA information. So here we can see for the step area, and the summary RSA is a type 3 RSA, right? Type 3. So we can receive the type 3 RSA information. Okay, and then we will reject type 5 RSA information, because the type 5 RSA means the external network information, right? And for the type 4, it's the same. It's describes the location of the ASPI device, right? Okay, so for the step area and the type 5 LSA information of external networks cannot be floated to the step area. It means for the step area, just can receive the type 1 LSA information and type 3 LSA information, but will delay the type 4 LSA information and type 5 LSA information. So because we can't receive and reject the type 5 LSA information, so the step area can't do the redistribution. It means we can't set the ASPI device on step area. Okay. And next is for the flapping in step area. So the flapping happens in our network, and for the step area actually can't receive the detailed information about the external network. So if you lose the routing entry or then update the routing entry, for the step area, it's not change anything because we can't receive the LSA information, and also we can't add this LSA information to our database. Okay, so if you lose or update your routing entries about the external network, so we won't change anything. Okay, and next, import the default route LSA as a summary LSA to supplement type 5 as LSA that cannot be learned. So what does it mean? It means for instead of the type 4 and the type 5 LSA information, right? And we also have to need to communicate with the external network so that we use the type 3 LSA information to communicate with external network. So we use the 0.0.0.0, this type 3 LSA to access the external network instead of the detailed type 4 LSA and the type 5 LSA information. Okay, so this is the points of step area. Okay, next is the configuration example of step area. Here we can see for the RD, it belongs with the area 10, and now we want to set the area 10 to become the step area, right? And then we have to add into the OSPF 10, and then to set the OSPF with the area 10 to become the step area. So we use the area 10 step area, okay. And then we can find for RC, actually, it's an ABI device, belongs with the area 0 and area 10. So the RC device actually belongs to the area 10. We also have to set the step command on RC device. So we have to add into the OSPF process and then set the area 10 step. So if we want to do this command on RC device, so the RC and RD contribute the neighbor relationship successfully, so that the LSA information, the routing information can't transmit to RD. So here, please remember if you want to set an area to become the step area, so the router belongs to the step area, you have to use the area and then area ID and then the step this commands on every router belongs to step area. Okay, so this is the configuration example of step area. Okay, next we will introduce the totally step area. So actually for the step area and the totally step area, there is little differences between two types of area. Okay, and now we can see the totally step area is also have to reduce the number of LSA information, but for the totally step area also can reduce the type 3 LSA information. So here we can see for the step area, actually we reject the type 4 and type 5 about the external network, right? And for the step area, actually we can reject the type 4, type 5, and even though the type 3 LSA information. Okay, So here, for this topology, we can see, and the area 10, if we set the area 10 to become the step totally area, okay, and then the RD device can't receive the type 4 LSA information, right? And type 5 LSA information, because these two types is about the external network, right? And now, because this area we set to the totally step area, right? So for this area, routers can't receive the summary network information. It means we can't receive the detailed type 3 LSA information here. Okay, so this is the differences between step area, because the step area can receive the detailed information about the type 3 LSA information. But now for the totally step area, we not just to delay the type 5 and type 4, we also have to delay the LSA information of type 3, right? So now if the router want to communicate with the external network and also have to communicate with the inter area. So now the totally step area will deliver the default route. So for the default route, actually is the type 3RS information and 0.0.0.0. This router can help the RD device to communicate with the area 0 and also can communicate with the external network. Okay, so for the external network and the inter area, we also use the default route to communicate, to transmit our packet. Okay, and next is the totally step area cannot contain an NSBR. So it means we can't do the redistribution on totally step area. Okay. And of course, we can't communicate with the other AS device. We can't set the ASBR device with this area. Okay. And the next is area 0 cannot be configured as the totally step area. It means the backbone area, we can't set the backbone area to become the totally step area, because we know the totally step area will reduce the detailed information about the type 3, type 4, type 5. So if we set the area 0 to become the totally step area, maybe cause some problems or some errors on transmitting the packets between the non-backbone area and the backbone area. Okay. And next is the totally step area cannot be traversed by a virtual link. So here, if the area 10 connect with another area, such as area 2, right? So for the area 2 can transmit with area 0 and with area 20, we have to set the virtual link, right? And then we have to enable the virtual link on RCA device, and then another ABI device belongs to the area 10 and the area 2, right? This is ABI device. Okay, so if we create the tunnel between the RC and the ABI device between area 2, so we can't set the area 10 to become the totally step area, okay? Because actually the totally step area reduce the detailed information, so that even though we configure the virtual link between two routers, we can't learn the routing information. So here also we can see for the communication, and we use the default information with type 3 RS information and to communicate with others, and we delay the type 5 RSA, we delay the type 3 RSA, we also delay the detailed type 4 LSA. Okay, and the RC device actually can send the type 1 LSA information to RD, because the RC and RD belongs to one area. Okay, so this is a totally step area. And then we can learn the configuration example of totally step area. So here you can see, now we set the area 10 to become the totally step area, and we use the area and at the area ID. This is area ID. and then use a step no summary command on ABI device. So here we can see on this topology for RC device is the ABI device, right? And the RE is a totally step area router. And we have to go to the OSPF process. So use the router OSPF 10 and then set the area 10 to become the step area. Okay. And now we have to go to the RC because the RC is the ABI device for area 10. And then use the area 10 step no summary, this command. Actually, this command is differences with the area 10 step. We add the no summary command, right? Follow the area 10 step. This command actually to set this area become the totally step area. It means we can't receive the detailed information about inter area. We delay the detailed type 3 LSA information. Okay, so this is the configuration for the totally step area. And next, we will introduce the NSSA area. For the NSSA area, actually, we can say it's a not so step area. So what is not so step area? It means there is a differences between the step area and NSSA step area, right? Actually, for the NSSA area, we can set the ASBI device. We also can communicate with other external network. So we can do the redistribution on NSSA area. Okay, so the NSSA area is a special step area. And for the NSSA area is same with the step area because the NSSA area rejects the type 4 and type 5 LSA information. So for the NSSA area, we don't need to know the detailed information about the type 4 and type 5. Okay. So here we can see instead of the type 4 and type 5 LSA information, and we use the 0.0.0.0, these routing entries to access the network. Okay. And the default router is type 7 LSA information. So here we will see the NSSA area will generate a new type LSA information. It's a type 7. Okay, it's type 7. So instead of the type 4 and type 5, we can transmit the type 7 LSA information into NSSA area. And then the NSSA area connected with the external network, right? And with another AS, actually we use the RIP protocol. And then the RIP protocol routing information will connected with the NSSA area. So the RA device actually is the ASBI device. We have to do the redistribution on RA device, and then the RA device will transmit the routing information about the RIP AS to NSSA area, right? Okay, and then for other area actually doesn't support the type 7 LSA information. So how can we access to the RIP AS? So actually for the RB device, the RB device is the ABR device, belongs to the SSA area and the backbone area. We will transmit the LSA information through the ABR, and the ABR will change the type 7 LSA information to become the type 5 LSA information because the backbone area can recognize the type 1, 2, 3, 4, 5, but can't recognize the type 7. So now we have to do this action on ABI device. Okay, so the ABI device actually connected with an SSA area and the backbone area. Okay, and for an SSA area, if the SSA area want to communicate with other area and with the external network connected with other area or the backbone area, and we can use this default information to access. Okay. And for the type 7 LSA information can be flowed only in an SSA area, but cannot enter into the backbone area. Okay. So this is an SSA area. And For this page, we will learn more details about Type 7 LSA information because we know actually the Type 7 LSA information is special just for the SSA area. For the backbone area and the non-backbone area, or the special area such as the step area, totally step area, not support the Type 7 LSA. So we just floating the Type 7 LSA information within the SSA area, right? Okay. So now for the Type 7 LSA information, and we can see we also can call it an SSA external LSA information. And for the Type 7 LSA, it includes the link state ID. This means the destination network address outside the AS. Okay. And for the advertising router, it's the ASBR device. So here for this topology, the ADV router is the I device, right? And for the Type 7 LSA function, it generates the Type 7 LSA information for external network. So here, the I connect with the AS. So for this AS, we use the RIP protocol, and the RIP protocol will send the routing information to RA, and then we do the redistribution on RA, and then the RA will transmit the external information to an SSA area, right? Okay, so this is the Type 7 LSA. Okay, so for the Type 7 LSA, actually cannot transmit to another area, just can floating within an SSA area. So now for our SSA area, if we learned the RIP information from other AS, right? And then the RA will transmit to RB. So for the RB will receive the Type 7 LSA information about the link state is the 100.100.10, this segment information, right? This detailed LSA information. And then the RB will transfer to the backbone area. And now the Type 7 LSA information will become the Type 5 LSA information. Okay. And here we can see for the router reach the ABR device in the SSA, and the ABR in the SSA converts the router to Type 5 LSA. So the Type 5 actually is the external route, right? And then the transmits them to area 0, and for the area 0 can transmit to other non-backbone area. Okay. So for the Type 5 LSA information can transmit to the whole OSPF routing domain. Okay. But for the Type 7 can't transmit to other area. So this is Type 7 LSA information. Okay, for this page, actually, we can see the detailed content with the NSSA area, and we use the show IP OSPF database, NSSA external, and then we can see here is the Type 7 LSA information, right? Okay, and we can see the OSPF router with the 4 and process ID is 100. And this is an SSA external link state. It means this type is LSA Type 7, right? And then we can see the LSA and the options, LS tab, and the link state ID is from the 7.7.7.7. Okay. And for the advertising router is 4.4.4. And for the LS sequence number and checksum and length, and for the net mask information and metric tab information, and the other information, we can see the details here, right? And here is the encapsulation format for the LSA information. Okay, so it's the same with this packet, right? From the LSA option and the LSA tab and the link state ID, advertising router information. Okay, it's the same. So this is the detailed information about an SSA RSA. Then we can see how to configure the NSSA area. Now we want to set the area 10 to become NSSA area, right? And we have to, for this topology, actually the RB device, right? And the RC device, it belongs with the NSSA area, right? And for this area, we have to use the area 10 NSSA, this command, to set the RB device to become the NSSA area. Of course, we have to set this same command on RC device. We also have to use area 10 NSSA information. Okay. So now we can see a little difference here. We add the default information originate, right? Okay, so what does this mean? We can see the explanation here. Okay, and because actually in an SSA area does not deliver a type 3 LSA information to the NSSA area. So for the step area and totally step area, we know we will deliver the default route to the step area and totally step area, right? But for the NSSA area, there is a little different because we can't deliver the default route to the NSSA area by the default. So we have to use the command. So this command is a default information originate. It means we will use the default information originate to create the default route to an SSA area. Okay, so now if we use this command, it will generate the type 7 LSA information to an SSA area. And then we don't need to manual the 0.0.0.0, this default information on our routers, because for this command, the local routing table does not need to contain the default route. We just use the default information originates this command, and then the NSSA area will generate the default route, and we can use this default route to access the external network. Okay, so this is the differences between an SSA area and the step area. Okay, and here we also can see we use the redistribute command here. And for the RB, actually, this is an ASBR device, right? Because connect with another AS and the OSPF process. So we have to do the redistribution on ASBR device. And we ending to the OSPF 10 and do the redistribute connected subnets and redistribute the RIP metric 50 subnets. It means we redistribute the RIP to the OSPF. Okay, and then the RC can learn the detailed information about the other AS, about the external network by type 7 LSA information, right? And because the other area can't recognize the type 7 LSA information, so for the ABI device, it's the RC device, right? We have to convert the type 7 become the type 5. And then the area 0 or other inter-area device can use this type 5 LSA to access to the RIP AS. So this is the configuration about the NSSA area. And next, here is a totally NSSA area. So actually the totally NSSA area is reduce more detailed information on the NSSA area. Actually, we know the NSSA area delay the layer 4, type 5, 4, and the type 5 LSA information, right? So for the totally NSSA, actually, we reduce the detailed type 3 LSA. And for the totally NSSA, here is the configuration example. And if we set an area to become the totally NSSA area, and we can see the command is area 10 and SSA no summary is also at the no summary, right? Follow this command. Of course, we also have to set the no summary command on ABR device. It's same with the totally step area, right? And here for RC device, we adding to the OSPF process and set the area 10 to become the NSSA area and then add the no summary. It means we set this area can't receive the detailed type 3 RSA information. Okay. And then for the RB, actually is the ASBR device, right? And then we have to adding to the OSPF process, do the redistribute for the external network of RIP, right? And then we have to set this area, use the area 10 to become the NSSA area. It's the same with the NSSA area, but the difference is between the totally NSSA, we just to have add the no summary on ABR device. So if we add this command for the ABR device, do not allow the type 3 LSA information from other area to NSSA, right? And we just can use the 0.0.0.0, this default route to access inter-area, of course, to access the external network with the backbone area or other non-backbone area. Okay, we can't to receive the type 3 or type 4 or type 5 information into the NSSA area. Okay, so this is the totally NSSA area. So now let's do a summary of the OSPF area. For the OSPF, actually we have different area, such as the backbone area, common area, step area, totally step area, NSSA area, and totally NSSA area, right? And for the backbone area, we just use area ID as 0, right, to identify this area is backbone area. And for the non-backbone area, we use the other number, such as the 1, 2, 3, 4, to identify this area is the common area, right? And for non-backbone area, have to connect it directly with backbone area, right? So if we connect the non-backbone area directly with non-backbone area, we have to create the virtual link to solve this problem, right? So for the common area, we can receive the inter-area router, inter-area router, and external router. This means we can receive the type 1, 2, 3, 4, 5 LSA information and then to build the LSADB, right? And to reduce the LSA entries and to let our device work better, so we suggest we can use a special area such as step area, right? And for the step area, actually, it can block the unnecessary external route. So we can't receive the type 4 and type 5 LSA information from other area. And for step area, actually, if we want to access the external network, we just can use the type 3 LSA information because if we set one area to become the step area, the ABR will generate the default route to step area. So for the step area device want to access the external network, and we can use the default route. And for the step area, actually, we can't do the redistribution, so we can't set the ASBR device. We can't to connect the step area with the external routes directly. Okay. So for the totally step area, actually we know it's reduced more detailed information based on the step area, not just for the type 4 and type 5 areas information. We just reject the type 3 areas information. So here for the totally step area, actually, if we want to communicate with the inter-area or intra-area, we also have to use the default route 0.0.0.0. Okay, we delay the details about the type 3, type 4, type 5. Okay, And after this, actually, we learn the NSSA area, right? The not so stem area. It means we can do the redistribution. We can set the ASBR. We can connect NSSA area with the external network directly. Okay, so this is the differences between step area and the NSSA area. So for the NSSA area, actually, we will generate a new tab. It's a tab 7 LSA information. But for the tab 7 LSA information, actually can only be flowed in NSSA. So if we want to transmit the route information to other area, we have to convert the tab 7 to become the tab 5 RSA information into other area, so that like the backbone area, other non-backbone area can access the external network which is connected with the NSSA area. Okay. And for the NSSA area, we have to remember the ABR belongs to the NSSA area cannot generate the default route. So we have to use the command is the default information originate and generate the default route. Okay, so this is another differences between the NSSA area and the step area. Okay. And then is a totally NSSA area. And for the totally NSSA area, actually it's reduce the more detailed LSA information based on the NSSA area. We reject the tab 3, tab 4, and the tab 5. And if we want to access other network, if we want to access other area, we use the default route and to access other network and other area. For the totally NSSA area, actually we don't need to menu the default information originates this command, because for the totally NSSA area, the ABR will automatically generate the default information to our totally NSSA information. Okay, so this is the summary of OSPF areas. And next, here is a comparison between OSPF area and LSA tabs. So for the different area, we have set the backbone area, non-backbone area, and non-step area, totally step area, NSSA area, and totally NSSA area. Actually, for every area, we have the tab 1 LSA information and tab 2 LSA information, right? Because the tab 1 and tab 2 is floating just within one area. Okay, and for the tab 7, actually it means the inter area between two areas, right? So for the backbone area and non-backbone area and the step area and the NSSA area, we can receive the detailed tab 3 LSA information. But for the totally step area and totally NSSA area, actually we reject the detailed information for tab 3. But if we want to access the network, we can use the default route 0.0.0.0, and this default route is tab 3 LSA. Okay. And then for the tab 4, just for the backbone area and the non-backbone area, non-step area can receive the tab 4 and tab 5 LSA information successfully. But for step area, totally step area, NSSA area, and totally NSSA area can't receive the external LSA information. Okay. And for the tab 7, actually we know it's special for NSSA area, right? So just the NSSA and totally NSSA supports the tab 7 LSA information. Okay. Other area can't receive the tab 7 LSA information. If we want to communicate with the AS, which is connected directly with an SSA area, so we have to use the tab 5 LSA information, right? And which is generated by the ABR device belongs to the an SSA area, right? Okay, So this is the comparison between OSPF areas and LSA types. So this is the part to introduce the special area.